Hello, welcome to the first video in the series on A-level calculus for year 13. So we're just going to do a quite quick introduction to the chain rule. So this recap should show you what you need to know coming into this, just basic differentiation of the sort of basic functions. So if I scroll down a bit, do you all know how to differentiate these three functions? If you want to take a little time to do it yourself, pause the video. Otherwise, you can follow along with me. Just a reminder, this is from last year, the polynomials. So if we differentiate polynomials, we multiply by the power, reduce the power by 1. When there's just an x there, we get rid of the x. And if there's a number that needs differentiating, that just vanishes. So if you haven't covered differentiating trig like sine x, cos x, or if you haven't done e to the x or natural log of x, you can still watch this video, but some of the stuff won't be as familiar, but I'll show you what you get. So differentiating sine x, we get dy by dx equals cos x. If it's e to the x, it just stays the same. And natural log of x becomes 1 over x. Okay, that's all the different functions we'll be looking at today. If you wanted to differentiate cos x, you get minus sine x. Like I said, I'm assuming that you've already covered that, but if you haven't, it shouldn't cause too many problems. The chain rule is used in situations when we have a function of a function. Okay, so f of g of x. So if you've done the chapter on functions, you'll be familiar with composite functions, which are fgx, but it just means you do a function of a function. Okay, so we take one function of x and we use it as the argument for another function of x. So just quickly, if you can look at those, I've listed a few functions down here: e to the x squared, 5x plus 2 to the half, cos of x to the 4, x log 4x, sine x over 3x squared, and cos x sine 2x. Can you identify which of those you think is in the form fg of x? So it's a function of a function. We've just taken one function and used it as the argument for the other. And which ones are not. Okay, so if we look at these, e to the x squared, if we add brackets here, it's easier to see. This is two functions, e to the x and x squared, y equals e to the x, and y equals x squared, and we're doing e to the x squared. So that is a function of the form that we're looking at today, a function of a function. What about this one? This 5x plus 2 to the half. One of the functions is 5x plus 2. The other function is x to the half. So this one is a function of a function. Cos of x to the 4. That again is a function of a function. We've got cos x and x to the 4. And then x log 4x. This one is not a function of a function because there's two functions being multiplied together here. We've got f of x would be f of x equals x, and g of x is g of x equals log 4x, and they're being multiplied together. So that one is not of the form that we want. If we wanted to differentiate that one, we'd have to use the product rule. This one, again, is not a function of a function. This is a function divided by a function. And that one, we would use the quotient rule. And this last one, again, is not a function of a function. Written in its current form. There might be some transformation you could do to make it look like it's a function of a function, but that is just two functions multiplied together. Okay, so the top three are examples of things that we can differentiate using the chain rule. The others we would use the quotient rule or the product rule for. So we're going to look at an example. And I've written the method. I've written the method in a box there. Now, the chain rule technically is can be expressed like this. We could say dy by dx equals dy by du times du by dx. Okay, so that is the chain rule. Now, what we could do to use that formula that I've written in green there, we could substitute one of the functions for u. So in that example we've got there, I could make u equal 5x plus 7, and then I'd be able to find dy by du and du by dx and multiply them together. That is very unwieldy, though. It's an awkward way to approach it, and you're expected to be able to do these differentiations without having to write down a substitution for u. So the method I've written on the right is basically the formula that I've written in green, but written as a more of a sort of cheat sheet so that we can do it quickly. Okay, so what we do is, first of all, step one, we pretend the bracket is just x. So we pretend that this is x here. So all of the 5x plus 7 we are going to treat like x. Okay, so that means that we are now pretending that this is just y equals x to the 5. Okay, so if it is y equals x to the 5, we know how to differentiate that. We take the power and we bring it in front and reduce it to 1. So we would get 5x to the 4. Now, obviously, we're only pretending that the bracket was x, so it's not really x, it's 5x plus 7, but so we'll write the 5x plus 7 in there. So that was step 2. We differentiate it as if the bracket was just x. And then 3, we've got to multiply by the derivative of the bracket, of the contents of the bracket. So we write a multiply afterwards, and we now look inside the bracket and we differentiate 5x plus 7. So if I differentiate 5x plus 7, I'm left with 5. So that means I need to multiply by 5. And that is those 3 steps are the process we'll go through for every chain rule question. You forget the contents of the bracket and just act like it's an x, differentiate, and then you multiply by the derivative of the bracket. This should be simplified because we've got 5 times 5 there, so we need to put 25 5x plus 7 to the 4. Okay, most of the chain rule questions you come across do look like this. They're like a bracket with a power. However, it applies to other functions of functions. So here we go. We've got 3 more examples here. Okay, so for the first one, we first of all pretend that the contents of this bracket is just x. So we get dy by dx equals, well, e to the x stays the same, doesn't it? So we just e to the x, but x is really 3x minus 1 in this case. So that's our first 2 steps of the 3-step process done. We treated the bracket as if it was just x and differentiated. Now, e to the x just stays the same, so that's what we did. But then we need to multiply by the derivative of the bracket, which was 3 in this case. Now, that looks a little bit awkward. We don't really write maths like that, so I just need to rewrite it with the 3 in front. Now, obviously, it's absolutely fine if you just wrote the 3 in front straight away. You don't have to write the 3 afterwards and then go back and change it. Okay? So incidentally, that's why e to the 5x differentiates to 5e to the x. It's because of the chain rule. And then for this one, we treat it as if the bracket is just x. So we're going to differentiate this as if it was just sine x. Now sine x goes to cos x. So this becomes cos of our x, which is x squared plus 1. And then we multiply by the derivative of the bracket. Now this time, when we differentiate the bracket, we don't just get a number like we did before. Doesn't matter. We do the same thing. We differentiate the bracket. That gives us 2x, and we multiply by 2x. And again, that looks a bit awkward, so I'm just going to rewrite that with the 2x in front. And as you get more confident with doing these in your head, you won't need to write these as 2 steps. I'm setting it out like this so we can see the 2 steps that we do when we differentiate this. We first differentiate normally, then multiply by the derivative. But obviously, you can speed that process up by just writing the 2x first. D, I should have put a y equals there. Anyway, so let's, I didn't put y equals on part C either, so that was slightly wrong. So first we need to rewrite this because this, we don't really know how to differentiate square roots unless we write them as a power. So when we get a complex sort of square root situation, we can differentiate by writing the square root as a power of a half. So now again, we're just going to differentiate it as if that bracket is just x. So if that was just x to the half, so ignore all the complicated stuff inside the bracket, we're just going to treat it like it's x at the moment. So if it was x, that means that this half up here will come in front, and then we reduce the power by 1. So we will get a half x, but obviously our x is really 3x minus x squared minus 8. And then we subtract 1 from the power, so that becomes minus a half. And then we've got to multiply by the derivative of the bracket. Now, if we differentiate that bracket, we get 6x. So we've got to multiply by 6x. Okay, and again, that's a little untidy because we've got half at the front of the bracket and 6x afterwards. So we just need to collect them together. A half times 6x is 3x. And we've got 3x squared minus 8 to the minus a half. Okay, so I've got an exercise where this first exercise, all of the questions are of the type polynomial function of a polynomial function. These are the most common. It's like the first example we looked at. Okay, so I'm going to ask you to pause the video in a second so that you can take some time to work these out. If you want to pause it and do the first question and then unpause it, just to check that you're doing them right. Okay? Okay, so if you've had a go at part A, continue. So if we differentiate 1 plus 2x to the 4, we treat it as if the bracket is just x. So it becomes 4, 1 plus 2x cubed. But then we've got to multiply by the derivative of the bracket. So we've got to multiply by 2. Then we tidy that up, and we get 8, 1 plus 2x cubed. Okay, so again, that was the first question. If you would now pause the video and I will go through all of the rest of them in a moment after you've had a go at them all. Okay, so hopefully you've had a go at all of them now. I'll just quickly work through these. So I'm going to work out each one of them so you can see the thinking behind it. So b will be -5, 3 minus 2x squared to the -6 times minus 4x. And that simplifies to 20x, 3 minus 2x squared to the -6. Part C becomes 1/2, 3 plus 4x to the -1/2 times 4. So that becomes 2, 3 plus 4x to -1/2. So D is like x to the 7, so it becomes 7, 6x plus x squared to the 6. And we have to multiply it by the derivative of the bracket. This is the first example where we've actually got two terms when we differentiate the bracket. So because the whole of the derivative is being multiplied by what we have, we need another pair of brackets. So this becomes 6, because 6x differentiates to 6, plus 2x. And we do need brackets around that. The whole of that is being multiplied by what we have before. We could leave it like that. That would be fine, but we have got a common factor of 2 there in that second bracket. So we could take that factor out and we get 14 6x plus x squared to the 6 times 3 plus x. And then E. Well, for E, we need to rewrite that as 3 plus 2x to the -1. So when we differentiate that, it becomes -1 times 3 plus 2x to the -2. And then we multiply by the derivative, which is 2, giving us -2, 3 plus 2x to the -2. And that's E. So for F, again, if we go back up to the question, I'll rewrite F. It needs to be written as 7 minus x to the 1/2. So for F becomes 1/2, 7 minus x to the -1/2, times by -1, because when we differentiate 7 minus x, we get -1. And that simplifies to -1/2, 7 minus x to the -1/2. Just scroll down a little bit. G. We've got, treat this as if it's just 4x to the 4. So we multiply the power by the coefficient. So we get 4 times 4, 16. 2 plus 8x cubed. And then we've got to multiply by the derivative, which is 8. And then we need to work out 8 times 16, which is 128, times 2 plus 8x cubed. And finally, H, treat this as if it is 3x to the -6, so it becomes -18, 8 minus x to the -7, times by the derivative, which is -1. So that just cancels out the minus sign we had before, so it becomes plus 18, 8 minus x to -7. Okay, so let's try some different functions now, not just polynomials. We've got some of the same idea, but we're just using different functions now. So, for example, have a quick go at part A, and then I'll go through it in a second now. Okay, so for part A, We're going to treat the bracket as if it's just x. So the bracket is hiding. The bracket is the power of e to the x. So the bracket is cos x. So we treat it as if it's just e to the x. So it stays the same. Then we've got to multiply by the derivative of that bracket. Now cos x differentiates to minus sine x. So we're going to multiply by minus sine x. I'm going to rewrite that because we don't actually need the brackets around minus sine x. So I haven't done anything simplifying this. I'm just tidying it up slightly. Okay, so now pause the video, have a go at the rest of the questions, and then unpause and see how you do. Okay, so hopefully you've done or attempted all of the questions you can. So for part B, treat this as if it's just cos x. So it becomes minus sine of 2x minus 1. Then we multiply by the derivative of the bracket, so put the 2 in front there. So there we go. I'm just speeding that up slightly from what we were doing before. I've just gone straight to the final answer without having to tidy up, which is fine. C, I'm going to rewrite as natural log of x to the half. So that is going to be we're going to pretend that's just x to the half. So it becomes a half log x to the minus a half. But then we've got to multiply by the derivative of that bracket. The derivative of log x is 1 over x. And so that tidies up to 1 over 2 times 1 over x. So that's 1 over 2x times log x to the minus a half. That's fine as a final answer. However, I'm just going to, because the question used a square root symbol rather than the power half, I'm going to put it back. I'm going to put that square root symbol back in. Now we've got a negative power, so the square root of log needs to go on the bottom of the fraction. So we'll just write it as 1 over 2x root log x. Either answer is totally acceptable, though. D. Okay, so for part D, I think I'm going to go onto a new line because it looks quite long. So part D, so we treat this as if it's just x to the 5, so it becomes 5 sine x plus cos x to the 4. And then we multiply that by the derivative, which is cos x, because sine x differentiates to cos x. Cos x differentiates to minus sine x. So that's the solution there. By not writing the times symbol, I've allowed myself to just have the final answer in one step. Part E, treat this as sine x. So when I differentiate it, it becomes cos of the bracket. Now we've got to multiply by the derivative of that bracket, and the derivative of that bracket is 6x minus 2. There's a common factor there of 2, so I'm going to take that out as well. So we get 2 bracket 3x minus 1 cos 3x squared minus 2x plus 1. F, natural log of sine x becomes 1 over sine x. Then we've got to multiply by the derivative of sine x, which is cos x. And tidying that up, that becomes, we'll put times there, that becomes cos x over sine x. Okay. If you've covered the year 13 trig, you'll recognize cos x over sine x as being cot x. So if you could call it that. If you've covered that, if you haven't yet, you will. Cot x is the cotangent of x, which is cos over sine, compared to the tangent of x, which is sine over cos. G. So we're going to treat this as if it's just 2e to the x. So it just it just becomes 2e to the cos 4x. Nothing happens with e to the x. And then we've got to multiply by the derivative of that bracket. So cos 4x becomes minus 4 sine 4x. And tidy that up a little bit, we get minus 8 sine x e to the cos 4x. And that was sine 4x, wasn't it? Not sine x. Yeah. And then h. Just treat it like it's cos x. So it becomes minus sine e to the 2x plus 3 multiplied by 2e to the 2x. Which again is actually fine, fully simplified, but I wrote the multiplication symbol, so let's write it again. Minus 2e to the 2x sine e to the 2x plus 3. Okay, and that completes the solutions to that exercise, and that's the end of this video. If you want to do more practice on chain rule, I encourage you to go to your textbook. When I've finished the next couple of videos on calculus, we're going to look at some past exam questions about differentiation as well. So check that video out if you wanted to look at some past paper questions that might be a bit more challenging than these examples. But yeah, for now, thanks and see you later.